Can we run it and
So,
prove it?
well, yeah, I mean, I'm running it right now. The creation of a method does not actually impact our program whatsoever. What we must do is we must invoke the method. So what I'm going to do is I'm going to say hello, and I'm going to put this on top of every single right line. And then run this, and we get this output.
Now leave
So
that,
what's going on?
yeah, leave that up while you're explaining the flow of execution here.
Right, so what's going on is that, oh, come on, seriously, Visual Studio? You know, Display Fusion used to have this little button that said always on top. I like
You
Display
could just
Fusion.
like drag that back over and not worry about clicking. Just use your mouse to point. I mean, it is
Oh,
a
I could do that
pointer.
too. Yeah, it is a pointer, I suppose. Okay, so what do we have going on here? We have two things that are new for today. A method definition, which there is only one of, and we have method invocations, which there are now 4 of. A method invocation follows a particular syntax. And again, when learning syntax, you kind of have to take things for granted. You kind of have to think, okay, I'm learning a new language. This language has rules. What are the rules for invoking a method? Well, you have to identify the method, and I'll go ahead and click on that so we can see the relationship between these words. You have to identify the method by typing in its name. Then in this case, what we're doing is we're opening up and immediately closing parentheses, which the existence of these parentheses will become very, very self-evident shortly as we talk about what methods can do. Finally, because this is a line of code, we have to terminate it using the semicolon. So what happens when we have a method invocation? So this is a method invocation, but what happens when main hits one? Remember, program execution starts at main. It starts at line 6, and it'll end at line 20. Once we hit line 20, the program is done. But that's not to say that execution is constrained within main, because methods allow us to jump from one part in our code to another. So what's going on here is that on line 7, we have an example of a method invocation. Execution is going to jump from line 7 all the way to line 23 when the C# compiler sees that we have a method invocation. So on line 7, we start off just looking at line 7, and then we jump all the way to line 23 into this block. This block will follow the exact same rules as main, in that execution will start on line 23, continue for every single statement within this block, and then exit on line 25. Once the method exits, methods will always return to their caller. The caller of a method is simply the line of code that executed the method using a method invocation syntax, which again we see an example of here on line 7, 10, 13, and 16. So right now we have a method that has a single line of code in it. And I said that the method will behave like main in that it will sequentially execute lines of code until it's done. And I can prove that too by doing another console write line. Now watch what happens. Something crazy is going to happen. See? Watch when I hit F5. Boom. This second line of say hello is now printed 4 times. Why is it printed 4 times? Well, it's printed 4 times because we've invoked it 4 times. So again, on line 7, when we invoke say hello, we jump all the way to line 23. We execute every single line of code in sequence until we reach the end of the block. When we reach the end of the block, we go back up to the invocation.